Today we're going to be talking about advanced trigonometry. In particular, in this video we're going to be looking at exact values for the three trigonomic ratios, sine, cosine and tangent, and kind of explaining where they come from. So the way we do this is we need to look at two triangles. So the first one I want to look at is a right angle triangle where these degrees here are the same, and this is a right angle triangle, and we'll say that this is 1 unit, that is 1 unit, so they're the same. And then we can use Pythagoras Theorem to find this side length here, and we know it is root 2 over here. So if this was the case, this triangle, if we had this triangle, what is this angle here? Well, there's 180 degrees in the triangle. We've already got a 90-degree angle here, so now we've got 90 left, and we said that these two angles have to be the same, so these angles have to be 45 degrees each. So using this, we can find the exact value for 45 degrees using this triangle here. So let's do that. Let's start with sine. So sine 45 degrees is equal to what? Well, okay, so we can choose any of these two angles here. They're the exact same. Let's focus on this one. So sine is equal to the opposite 1 divided by the hypotenuse root 2. Great, okay, well, let's talk about cosine then. Cosine 45 degrees. So in relation to this angle, cosine of 45 is equal to the adjacent 1 over the hypotenuse root 2. And what about the tangent? Tan of 45 degrees, well, tan is equal to opposite divided by the adjacent, which is 1 over 1. So now we can start to now we have some exact values here, and I want to rationalize these two here just so we can see what they come out to. So I've already rationalized them beforehand. These are root 2 over 2 and root 2 over 2. So, and we'll just make this equal to 1. So now let's look at a different triangle, a 30, 60, 90 triangle. Well, how are we going to get a 30, 60, 90 triangle and work out its lengths? So the way we're going to do that is we're going to start with a equilateral triangle. So here's our equilateral triangle here, and so what we know is all these sides are the same, all of these angles are the same, and that's what an equilateral triangle is. So let's pick 2, and you'll see why we use 2 in a minute, and we're going to split this triangle in half, right down the middle here. So what happens is this becomes 1, this side becomes 2, and this side here, using Pythagoras Theorem, has to become root 3. So let's redraw that triangle. Okay, so looking at this triangle here, we know that that was a right angle because we went directly down the middle here. So that means this here has to be 60 degrees because an equilateral triangle has 60 degrees in all of its corners, and this has to be half of 60 degrees, which is 30 degrees. So now we can find two of the different exact values using this triangle here. So I'm gonna set up a table to the side here so you can actually see some sort of pattern, if you will, over here. Okay, so here we have our table of values here of the exact values. So if we wanted to find the sine of 45 degrees, we find where these two, this row and column intersect, and we find root 2 over 2, and that is the exact value. So now we're going to do the same, but with 30 degrees. So where's 30 degrees on our triangle? Well, it's right over here. So now sine is equal to the opposite divided by the hypotenuse, 1 divided by 2, and we get 1/2. So cosine of 30 degrees, well, that's equal to the adjacent divided by the hypotenuse, and we get root 3 divided by 2. What's the tangent of 30 degrees? Well, it's the opposite 1 divided by the adjacent, which is root 3. And I'm going to leave it like this for now, and you'll see why. Alright, so now let's look at 60 degrees. So sine of 60, so we'll look at this angle here, opposite, divided by the hypotenuse, root 3 divided by 2, and cosine of 60, that's the adjacent divided by the hypotenuse, 1 over 2, and tangent of 60 degrees, that is opposite, root 3 over 1, which is just root 3, but let's just write the 1 for now. So these are our exact values here. So is there a nice way to remember them? Well, yes. You can remember that sine is 1, 2, 3, with root 1 over 2, root 2 over 2, and root 3 over 2. And you can remember cosine is just backwards. It's root 1 over 2, root 2 over 2, root 3 over 2. You can start to see some sort of relationship between these two. And for tangent, you can remember root 3 on the bottom, and root 3 on the top, and then just 1 for 45 degrees. There isn't really a nice trick for remembering the exact values like there is for sine and cosine. So that's my video on advanced trigonometry part 1. If you have any questions, feel free to leave a comment or contact me on social media, and I will see you in the next video.